Today I will tell you about the project we Meme Solutions did together with Gemius about automatic ad categorization. So what is our problem? One of the Gemius projects is called AdReel, and this is a tool that lets you monitor and analyze online marketing campaigns. And it lets you answer questions of the type, what percentage of car ads were for Mercedes, for example. And the data here is completely made up, so don't take business knowledge out of this, but this is the type of information you can get. So maybe you're a car producer and you want to monitor your competition. And you want to know what percentage Volkswagen car ads were there last month out of all ads about cars. Or maybe you would like to know how many people saw the new iPhone ad. And this is valuable knowledge for certain companies. And how it works is that every ad gets a brand assigned to it. So for each ad, you want to know what is advertised exactly. And currently, there is some automated solution that does not use machine learning, and there is human work. So human employees of Gemius see the ads and they say, okay, this is an iPhone, or this is a fridge. And of course, the challenge is to replace this whole, or replace the human work or part of it with machine learning. So let's try this. Okay, and can you tell me what is advertised here? So this is a piece. You go to the website, you turned off your ad blocker for whatever reason, and this is what you see. So can anyone tell me what is advertised on this? Sorry? Mercedes-Benz. Yeah, that's a nice first answer, because clearly there's a Mercedes on the picture. But in fact, if you would look at Adam Mauer's shirt, there is in tiny print written Mercedes-Benz Sosnowiec. And the ad is actually not for Mercedes-Benz, but for a car dealer that is located in Sosnowiec that sells Mercedes cars. So there is two different things. Mercedes-Benz could have its own ads, but also a particular car dealer can have their own ads. And you need to tell the difference. So this is the first type of problem we'll have with this type of data, is that it's not clear what is the correct answer. Right? You cannot just say, okay, I see a Mercedes, this is a Mercedes-Benz ad. So let's try maybe another example. Oh, so yeah, the answer is the car dealer from Sosnowiec. And this is the ad, one that I saw when I turned off my ad blocker. And the text says, share the croissant. For non-Polish speakers here, the text is share the croissant. So can anyone guess what's type of organization or? NGO, yeah, charity. This is the type of answer. Yeah, it's very hard to guess this answer because you don't know the list of all possible answers. So it's pretty hard to guess the correct answer, but the answer is charity. And on the picture, there isn't anything related to charity that much, right? There are St. Martin's croissants, which are very tasty, but they have, in general, nothing to do with charity. So not only, it could be confusing what exactly is advertised, you could also have on the images things that are not related to the product being advertised. Okay, so the third one and the final one of this, this is egg yolk, by the way. And the English text says, one component, many properties, speeds up burning fat by 57% and lowers cholesterol. This is also an ad you can see on the internet, and you also need to classify that. So maybe any guesses? Malware, yeah, that's a good guess. This time it's not malware, it's another type of scam. This is the weight loss drugs. Okay, so there's a whole part of market that sells kind of not working drugs that promise you weight loss. And there's nothing on this picture that indicates this is, so maybe if you analyze the text, then you can guess that this is about weight loss, but nothing on the picture tells you And this could be about weight loss, like why the egg yolk, I don't know. So, but these are the things you can see on the internet. Okay, so what is the data here? So first we have the ads, and the ads have many possible channels. They can have an image, and about 50%, a bit more than 50% have it. So the image could be like the charity ad we have seen already. The ads can have text, and more ads have text, and the text could say share the croissant, and it could be a separate thing from what is written on the picture. Right? So there is a picture that can have some text, but then there is also a separate text of the ad. And there is also the link that leads you to the target website. So a website where we can learn more about the product, we can maybe buy a product. So this is three types of, say, input data that we have. And then we have a very big list of brands. Sorry. Oops, something went wrong. Sorry about that. So we have 30,000 brands per country, which range all the possible things that can be advertised on the internet. So we have like foods and drinks like Coca-Cola. We have cars, we have shops, charity, various electronics like phone brands, but also particular phone models. Like maybe the new iPhone 7 is you need to know is this ad is particular for iPhone 7. But also smaller companies like the car dealer from Sosnowiec. And also the big brands like Allegro, Facebook, Google. So this list of brands is extremely diverse, not very related. So for different industries, you have different depth of the categorization. Sometimes you need to say, okay, this is a Mercedes car, and sometimes you need to say this is the particular model of a phone. So this is already looks like a very hard problem. And to make matters worse, you need to do this for 7 countries. So there is France, Germany, Poland, Romania, Russia, Turkey, and Ukraine. So not only different countries, but different alphabets. And every country has their own list of brands. Okay, so this looks very, very hard. And how to solve this? So the first instinct is to use deep learning. You know, everybody uses deep learning for something, or almost everyone. But we didn't go with deep learning, and why not? It seems that this is the intuitive answer, but there are problems with this data set. I already have shown you the pictures, and they are very diverse. There are different brands could have similar images, like the Mercedes could have the Mercedes cars, obviously, but also the car dealer can have the Mercedes cars. There is not enough data for each particular brand. There are some brands for which you will see only 1 ad, maybe only 5 ads. In total, there are like a few hundred ads daily, categorized by people. So it's not really, when you have 30,000 brands to assign, few hundred ads a day is not enough. Okay, and you can really easily overfit. So maybe you would see an ad of a fashion shop, right? When there is a lady in a dress, and there is a name, of course, of the store on the ad. But you know, what makes it different from other fashion shops with other ladies in other dresses? It's not clear. Or maybe the ad that we have already seen, you know, the car dealer from Sosnowiec that uses, that employs Adam Małysz to do their advertising, right? Even if I can train my deep learning model perfectly, and it will generalize greatly, and it will learn that Adam Małysz plus Mercedes-Benz equals Mercedes-Benz Sosnowiec. You know, next month or next year, this will change, right? They will hire someone else, and this will completely break. So this analyzing images seems to be a very hard way to solve this problem. So we tried something else. And the ads I have shown you very often have text on the image. And we already have some text. We already have text of the ad. we have the URL that links you to target website. So the idea is to extract as much text and then try to do, the first idea is to take as much text as you can and try to do something with it. So we could take the text of the ad, we could take the text from the target website, but we can also try to find and identify logos in the picture. And we can find the text in the picture using some OCR technique. So, and the end result here would be to find the text domodi get ready. And then do something more with it, of course. So what we did to extract text from images, we used two techniques two tools for OCR. We used Google Cloud Vision and Tesseract. Tesseract is an open source tool library for extracting text from images, and the Google Cloud Vision is the Google Cloud's machine learning solution. And when you run this ad, say, through this, the Google Cloud Vision actually works perfectly. So I don't know if you can read the Mercedes-Benz Sosnowiec on this image, but the Google Cloud can. Well, Tesseract doesn't do as well, but there are some cases where Tesseract outperforms DCV. And maybe let's try one more image, the charity that we tried. And then the Google Cloud works quite well, but there are some imperfections. So there is a certain drag and drop website where you can just drag and drop image and it will tell you what the Google Cloud finds. And this is what it found. So it found the text correctly, and then it found some random word that is not there, similar to the previous one. So we know where it came from a bit, but this is unclear. And the Tesseract does okay job, but also not perfect. And for logo, and I said that we'll extract logos, and we use Google Cloud Vision for this. So, and these methods were not perfect, obviously. And then like 50% of the ads that have an image got something from the Google Cloud. 20% got something from the got logo from Google Cloud, and 40% got some text from the Tesseract. Okay, and now we have this text, right? We took the ad, took the picture, we got some text extracted, and what is the simplest approach to assigning brands? Well, we will just look for the names of the brands. That is the first idea. Right? And when we do this, we find the Mercedes-Benz Sosnowiec that we want, but also we find the Mercedes-Benz that we don't really want. Right? This is not the correct answer. So we have now have the problem that we have some possible candidates for correct brands, but we have false positives. So we need a model to say which one is correct. Okay, so the solution will be take an ad, extract text, and find candidates, candidate brand names, and then predict which one is the correct one. This will be the scheme of the solution. How do we find the candidates? I already told you that we are looking for the brand names in the text. And here we could use certain strategies to find an exact matches, find each word in the text. Right? We could use permutations of words. We can try some other tricks, like find important parts of the brand names and look for them. Another type of strategy is to look at similar ads from the past. So maybe the ad have the same, so the ad have the target URL. So maybe the two ads have the same domain of the URL, right? They all lead to, say, sosnowiec.mercedes-benz.pl, right? If they both have the same domain of the URL, then maybe they are the ad of the same thing. So this is a possible source of the candidates, and maybe they have the same title of target website, or maybe some element of the target website is the same. So that's how we find candidates. Now we only need to predict which candidate is the right one. And we have our standard photo of Mercedes-Benz Sosnowiec. And we want to say the correct for the car dealer and the wrong for the car company. So we have a classic logistic regression problem. And how to solve this. So we build a model using one of many available algorithms. What could be the features? So we have the candidate, we have the ad, right? But we don't want to work really with text or image data. So we need to extract some features. And there are actually quite few we can calculate. We can find the brand of the candidate. We can use the brand of the candidate as a feature. We can also say how many candidates we have for this ad, right? If this is the only candidate, this is probably a very good candidate. But if there are like 10 candidates, well, it's less clear. We can say how many times this candidate was found, right? We have text from many sources. So we have the text of the ad, we have text extracted from the image, we have text from the target website. And if the same candidate was found from all three sources, it's probably a better candidate than just the thing that appeared once. So we also could have which exact methods found this candidate. Was it found in the logo? Was it found by the Google Cloud Vision text extraction? And we can also look at the past and say how many ads for this brand we have already seen. Right? Is this a big brand? Is this a small brand? Is this something we have never seen before? And also how often this candidate was correct. Right? If this is a candidate name that appears very infrequently, and every time it appears it's the correct answer, this is a different situation than, say, a candidate like Facebook, which can appear in many, many ads, and will very rarely be the right one. Okay, and to do the logistic regression, we tried many algorithms. So the crowd favorite XGBoost, LightGBM, which is an alternative to XGBoost developed by Microsoft. We also tried just logistic regression from a sklearn. We tried field-aware factorization machines, which also could be used for this. We tried online logistic regression, support vector machines. And out of this, we picked one that worked the best. Okay, and what else we could have done? Right? Because this was what we did, and what else could we try? So we could have tried one versus rest classification. Even after we found the candidates, we could have tried to build a model for each brand, but this is a very this has very little chance to work well because there are too many models. Like with 30,000 brands, you would need to build 30,000 models, and this already seems like it will not work. Right? Even if you train them in, say, 5 minutes, it would take you many days to train. And also, there are some brands are very rare, so they appear very rarely. So there is it would be very hard to train the model correctly for a particular brand. There is also a whole class of algorithms called hierarchical classification, where you use some existing hierarchy. So maybe you would group the brands into food and cars and iPhone and phones, and then use this hierarchy to make predictions. And we tried that, and it didn't really work well. And I guess the problem for us was that you need this good hierarchy to use, and we didn't really have that. There are also some approaches that try to create a hierarchy ad hoc from the data, but they also didn't work well for us for this particular problem. Okay, so the summary of the solution. What are the advantages of this? So this is almost language agnostic. The Tesseract library that we use depends on the language a bit, but other than that, you just need a list of brand names, in this language that you want to create the model for, and you are good to go. This is from NLP point of view, this is simple matching patterns in the text. There is nothing complicated here. So it scales really well. Like you want to do 30 countries? That's not a problem. Yeah, another one of this is that there is one model per country, which is all important for putting this thing in production, right? If we would have 1,000 models per country, that would be problematic to play in production, and the training is fast. Also, one thing I didn't put here is that it is possible for this algorithm for this approach to find the brand names it has never seen. Right? If there is a new brand and you haven't seen any ad for this brand in the past, it is possible for this algorithm to answer correctly. It is not easy and it will not always work, but it is possible. If the ad just has only this one candidate, right, that is a new brand, then our approach can find the correct candidate and give the correct answer. What are the disadvantages? So we didn't use any complex NLP methods. Right? One can imagine that you could use some text processing techniques to process the text of the ads and then get better results to improve the algorithm. But of course, you need to do this probably for every language separately. You need to employ some domain knowledge about the grammar of the language, and et cetera, et cetera. And there are some brands that are very hard to find this way. Say a brand Charity. Well, the name Charity will probably not appear in the text of the ad anywhere. So it's not not impossible, but it is very hard to find, say, Charity as an answer. And ideally, what you want to have from your machine learning system is that the cost does not depend on the number of ads you categorize, right? And here, this is not really true because the Google services cost money. They are not very expensive, but you break this assumption that you have a model that is, costs the same for any number of ads that you want. And this complete solution is now used by Adriel in their production. And that is all I wanted to say. If you would like to work with us on similar projects, talk with me or email us at jobs@mimsolutions.pl. Thank you.
Any questions?
I think you mentioned at the beginning that brands may be interested in the sort of volume of ads that is, say, delivered to their target audiences. Do you have a system for that that's, I guess, integrated with, or is it something that you're not looking at the moment?
To estimate the volume of ads that are...
So say, something is on the front page of Onet and something is on a blog somewhere. They would be weighted differently.
Yes, so this is... it covers, like, the Gamius has the system for this, and they... So yes, there is some mechanism like that, but I cannot really talk about it. And